Hello students, continuing our lectures on mathematical physics. So we will discuss about some special functions and some Untitled properties and differential equations in this lecture. So first we will start with Hermite functions. So a Hermite differential equation is given as y double prime minus 2x y prime plus 2 and y is equal to 0, where n is an integer from 0, 1, 2, 3, and the Hermite polynomials, that is the solution of this differential equation, are given as h and x, and it is equal to minus 1 to the power n e to the power x square dn by dxn into e to the power minus x square, and this is popularly known as Rodrigues formula. Now there are first few relationships based upon this Hermite polynomial. They are at h of x is equal to 1 into h1x h1x h0x is equal to 1, h1x is equal to 2x, h2x is equal to 4x square minus 2, h3x is equal to 8x cube minus 12x, and h4x is equal to 16x to the power 4 minus 48 x square plus 12. Okay, so how can you find relationship? How can we generalize this concept? You can see that if this is supposed to be your n value, if this is n, suppose take the last case, h4x, so this is n is equal to 4 here, so we have 16, that is to the power 4 into x to the power 4 minus 48 x square, means we have x to the power 4 minus 2 into 48, that is 4 into 12 plus 12, that is 4 into 3, and this is 4 into 12, so we can write it as equal to, if you consider this as the n, 2 to the power n into x to the power n minus n into 12 into x to the power n minus 2 plus 4 into n into 3 into x to the power 0. So this is for n is equal to 4. If we do the same thing, let's see whether we get these polynomials. So when n is equal to 3, using the same notion, it should be 2 to the power 3, that we are getting 8 into x to the power 3, 8x cube, minus you are getting 12. So it is n is equal to 3, that means 3 into 4, n into 4 has taken place, into x to the power 3 minus 2, that is 1. So this is n is equal to 4. Whereas in the case of if we take n is equal to 2, then also we have 2 square, which is okay, into x square, which is also okay, minus x to the power 2 minus 2, that is 0. So we will not have any value of x here, but what we will get is a value 2. So for this case, for n is equal to 4, it is n into 12. For n is equal to 3, it is 4 into 3, and for n is equal to 2, it is only 2. So let's try to understand how these values are coming. So let's write them once again. For n is equal to 4, we are getting 12 x to the power n minus 2, that is 4 minus 2. For n is equal to 3, sorry, it's 48. Take the value 48. This is sorted out. For n is equal to 3, we are getting the value 12, and for n is equal to 2, we are getting the value as 2. So based upon n, it can be said that this value is 48. That means it's 3 into 12. So n into 12 means 4. N into n. So 4 into 3, that means n. 4 into 4 into 3, for n is equal to 4 means n into n minus 1. So is it applicable for this also? Let's see. For n is equal to 3, if we have n into n minus 1, that means 3 into 2, so that will make it 18. So it's not working out. So what we can do here, to make it 12, it has to be n into n plus 1 if n is odd, and if n is even, let's see whether it is applicable for 2, n into n to the power 2, and it should be n into 1, so it should be 2 into 2 to the power 0. Somehow it's not working out. We need to work it out. So I keep it as an assignment for all those to find the value of generalized expression for these values. However, we do have a generating formula. So there is a generating function which says that e to the power 2tx minus t square is equal to n is equal to 0 to infinity h n x t to the power n by n factorial. This is the generating function for Hermite polynomial. And we do have some recurrence relationships as well. Recurrence relation for Hermite polynomial, and they are h dash n x is equal to 2n h n minus 1x h n plus 1x is equal to 2x h to the power h n x minus 2n h n minus 1x. So these are the recurrence relationship, and there are some other properties associated with Hermite polynomials. These are called the orthonormal properties. So let's write them in the next page. It's the orthonormal properties. So we have two relationships. First is minus infinity to plus infinity e to the power minus x square h mx into h nx dx is equal to 0, where m is not equal to n. That's the first relationship. And second relationship is minus infinity to infinity e to the power minus x square h nx whole square dx. This is equal to 2 to the power n into n factorial into root pi.